So this is the type of these are the tools, the climate tools that we use to assess information from the future. There are different scenarios, and these scenarios are related to the emissions levels. So here you see the projection of the temperature for the future using different emission profiles, different levels of intensity of the emissions, based on as well on different assumptions about how we are gonna mitigate or continue producing emissions. So these are possible futures that are divided into what we call scenarios. So this is what we use to say, okay, we don't know which is going to be the level of emissions in the future, so we assume like 4 main avenues, and we give this information to the climate modelers to tell us which is the climate in the future in these conditions. So this is when you are going to start navigating with all this data, you are going to come across these emission scenarios that have these names, RCP, recommended concentration pathways, for what is the project CMIP5, and as a more complicated name that is shared socioeconomic pathways, because in CMIP6 is more than just emission, is the way that we are gonna run the mitigation globally. So there's a lot of socio and economic aspects that are included. The numbers that you get with the name of the emission refers to the level of the radiative forcing. So how this models looks? So I'm not gonna run an evaluation because it's gonna take too much time, but I just wanted to give you just a flavor of how they look. So this is ERA 5 downscale with WRF at 3 kilometers. It's data from It's data from our colleagues at Vortex that run this downscaling. I have regrid, so I have downgrade the resolution to the typical resolution of the climate model, so that we can compare the same resolution. And this is how one example of one model looks in terms of wind. So I choose this one because this one is going to be used later on in another presentation. So I'm not going to go into all the details, which are the different, which are the bias, etc. No. I just wanted to show you on a first level, we are on track to describe the climate prediction. Obviously, MPI is not getting the circulation, the trade winds that get to the northeast of Brazil. That is a very important area in terms of wind developments, and there will be obviously other aspects that we could look. But in general, they get the spatial pattern because they reproduce the climate we have now, the synoptic activities, more or less, the mid-latitude circulations, the tropicals, etc. So this is to let you know that we don't have to look this data as we look to ERA 5. So they have other objectives, but they get a decent level of reality. This is the same plot for Europe. So we could say that this model really has a systematic bias especially on the Baltic area, on this region as a main, the first thing we observe. So they are not perfect, but they get a very complex variable like wind. They get it very in a good level. So how we look then the projections. So this is 3 maps of the climate model projections for the CMIP6 for the planet. Each of these map is for one of the emission scenarios. Okay, so remember what I tell you before: SSP2, 3, and 5. The number here tells you that the radiative forcing is higher, so the emissions are higher, and so you can, again, you can assess which is the kind of information that we can get if we want to compare changes in the next 20 years comparing to a baseline period. This represents an ensemble of 25 models and give us information about the percentage of change that we expect from these models. We expect according to different emission scenarios. It's very important that when we look to the next 20 years, the difference between the emission scenarios are not huge in terms of radiative forcing, increasing of global temperature. So you see here, you have which will be the increase of temperature with each of the scenarios. So it's not very different, but when it's different, it's by the end of the century. Then they diverge. But even, but even though we see some patterns of change, some areas that there are some footprints. And what you can, if this wasn't a school class, I would say, what you see? And I would say, I see pink in the north, I see green in the middle, no? So pink is what we could say as a first signal. And again, this is just to help you start looking to the data. Is the north hemisphere, we see that the signal of the models is to reduce wind speeds. And while in the tropics, especially Brazil, obviously there are some regions where they have not much wind, like Maritime continent or Congo. So yeah, a small change could be big, you know. So what is important then is there an explanation behind this pattern? It was and there's quite a lot of research, investigation, lies of evidence that basically what this map tell us that because the gradient, the temperature gradient between the poles and the tropics are becoming less intense because the poles are getting warmer faster. Let's say the energy that comes from this gradient, thermal gradient, reduce the kinetic energy in the mid-latitude, the jet streams. And this is like a cascade effect at the end, reduce westerlies on Europe. And then in Europe, there is also effects on, especially on this western part, that eastern part, that is also related to the circulation of the jet stream. This is a short explanation. There are in climate, there is no happy end, so there is not a perfect explanation for everything. So you start to ask for details, and you get more and more information, and you never stop. Otherwise, there will be climate seasonal prediction will be perfect because we know what drives everything, and we don't know it. So this is the same map for Europe. So if you start to use this map, you will say, okay, I have to worry in Poland. Baltics are getting a little bit better, and in general, we have Western Europe. We have regions where emerge with some changes that are significant. This is the ensemble mean. We need to look for the sake of time, because I'm very short. We need to deal with uncertainty. This is fundamental. So to assess which is the robustness, how many models point to one direction, whether some models are more good to represent wind conditions in Europe than others. These are multiple choices, multiple ways to tackle this, and it's really, really important at the end, because this is the first picture. This picture tells us just one aspect. Without uncertainty, these maps are incomplete. So this is the US. The presentation will be available, so you can then look it in particular. And Brazil with the convergence zone that's being accelerated with the higher scenario. So so then, and these are my 2 slides. So what we do now, we have a procedure to do the site analysis, the energy yield assessment. I took this from the CREAP exercise. It's a project that has been running a few Wind Europe technological workshops, so intercooperation of methodologies and results in energy yield assessment. And they show this like a summary of how you do your energy assessment. So what we do now, we put a factor in the regions where the signal is robust. We increase uncertainty, so we lower the P90. So we say, okay, this is uncertainty. Let's be more conservative in the uncertainty. This will be two possibilities. I guess the P50 is something that you need much more evidence because you need to justify this, because this has a directly impact on the evaluation of the revenue. Or you can then integrate this information like a risk management procedure, so a stress test, sensitivity analysis, etc. Something that you don't touch your standard procedure, but you use this information to see what are the risks that my project might be in danger. So this is the discussion that we need to have, not now, but during these years. Because if we don't do it ourselves, someone is going to do it outside. And I think the one who knows better these slides are the people from the wind resource. And I think the one that they really need to take the decision, which will be the best way to integrate this information. So this is all. There are many more things, but let's keep it talking.